Welcome everyone, this is the oscilloscope setup video. Let's start by turning on our oscilloscope. We can tell that this is our oscilloscope because it says oscilloscope up here. Let's begin by examining the oscilloscope probes. This is what the oscilloscope probes look like. I recall that these are the oscilloscope probes because this looks like it is a tool. It has functionality going on for how it is measuring things. It looks like a measurement instrument. This will be used to connect to the oscilloscope. This can be set on here or here. For our lab, we will not use this connection. We will be using the 1 and 2 channel connections. Once the oscilloscope is ready to go, we will preview how we set up the oscilloscope every time. So we can connect our oscilloscope probe. Now that we have the oscilloscope probe connected, let's review some important settings. To review the settings on your channels, press the 1 on this side. Firstly, we have our coupling. For this course, we are going to want AC coupling. We can select, use our entry scroll to change, and we want to press down the entry scroll if we want to change something. AC coupling is selected. Furthermore, for this course, we're going to want to check our probe. Our probe has a 10-to-1 attenuation. When we examine our oscilloscope probe, our physical probe, we can see that's on the 10x. That is the equivalent to 10-to-1. Those are going to be the key details for how to set up your lab. If you have interesting stuff going on that you don't quite understand what's happening, pressing the default setup button can get you into a very easy baseline to understand what's going on. And again, we can check. We have AC coupling selected, our probe's 10-to-1. Make sure to change that AC coupling. We can add another probe to this by just connecting it to the second channel. And again, for our second channel, we will want to press our 2 here. Now we can actually see that waveform is on the screen. We want to make sure that our second channel is set to AC coupling. We want to double check the probe. Probe 10-to-1, and let's check our probe setting. And we have 10x, or 10-to-1. Wonderful. Often, the probes may have a poor compensation. A poor compensation, to turn off the waveform, if you do not want to look at one, you can just press this, press it again, turns it off. You can see which waveforms are on over here. Zooming in vertically so we can see our edges of our waveform better. This is a well-compensated waveform. An example of a poorly compensated waveform, and for compensation, there we will take this screwdriver. If you do not have one, request one from your TAs based upon if you need one for your compensation. If your compensation was like this, you would not need one. However, an example of poor compensation would be this. This is poor compensation. To get a better compensation, we will take our screwdriver, insert it into here, and we'll just dial this until it rounds or squares off. And perfect. And to examine where we're inserting the screwdriver, it's into this hole. There's a screw in there for you to make sure that the compensation is correct. And you'll want to check both probes. And the ground is going to be on the right side for ground connected. And our probe is connected. Now, you see that waveform is moving, or rather it's a little hard to pick up on the screen. I'll manipulate the waveform a little bit so that you can see it slightly better. Doesn't seem to be like the previous one. We're going to adjust our trigger so that the waveform pauses. This can take a little bit of finessing. We can change our trigger source as well. Generally, the trigger source will not need to be changed in these labs. However, for my demonstration here, I wanted to show it off. And this compensation looks great. So now we're ready to move on to any measurements we may need to make.